Hi kids, this is chapter 19, day 2. So this will be Friday. And again, I'm out today, obviously. But on Monday, I'll go over these notes and I have a demo for you on this day that I'll do on Monday. And it involves solving for the R constant. And that's what this is all about, this next little slide here. Let me get the slide going here. Here it is. So R is the gas constant, and we solve for the gas constant, the 8.31. And I use all the units and everything like that. And I have this little lighter, and I'll show you with butane on how it works all out. But I'll do that on Monday. So today we won't get that demo, but we'll get the rest of these notes. So we're going to work on R, but here's the deal. I know that yesterday we talked a bit about Puvnert, PV equals nRT, and then at the end when I told you about like solving problems in the Split book, we're going to converting grams to moles using the periodic table. And then here's an example. So if I had 2.30 grams of sodium 2 moles, how would I do that? And if you looked on the periodic table, you'd see that sodium has a value of 23.0 grams per mole, right? And so in this case here, if I line up my units properly, it'll be 1 mole of sodium over 23.0 grams of sodium right here. And so this is how these grams are going to cancel out. So 2.30 divided by 23 gives me 0.100 moles of sodium. So just a kind of quick reminder, if you were having trouble yesterday, that's a little reminder of how you do that. Find everything on the periodic table. So in general, this would be this operation. What I mean by that is what I've done here is I've taken the mass. This 2.30 grams of sodium is the mass, and the 23 grams per mole is the molecular mass. I've taken the mass divided by the molecular mass. In this case here, mass is going to be little m. Molecular mass, anything you get from the periodic table, is capital M. And together, when we solve for moles, that's going to be N. N is going to be the number of moles. So here we go. So this is what we're going to do. We're going to take Puvnert and we're going to substitute in this little m over capital M, which is mass by molecular mass, for the N over here in Puvnert. So we have PV equals nRT. We're going to substitute in little m over capital M. It looks like this. Puvnert, or excuse me, PV is equal to little m RT, little Mr. T divided by capital M. Remember, the little m is mass, and this capital M is molar mass or molecular mass. So if we solve for molecular mass, and you guessed it, so if we solve for molecular mass, I can just switch with pressure and volume, and it should give me this M is equal to little mRT divided by PV. That's what it's going to be. It's this little equation right here. Little Mr. T is equal to PV. So in this case here, if you ever have any of the situation where you're working with gases and you have a mass and all these other variables, you can solve for the molecular mass. So what are the units of molecular mass? Give you a moment. And if you remember correctly, we said it was grams per mole. That's right, grams per mole. So all we're going to do is we're going to take this information. I'll back up. This information, let's read the problem. Suppose we measure the mass of the vapor of an unknown compound. That's it. It's an unknown. We don't know what it is. But we have a volume, 273 cubic centimeters. And we find the bulb that contains 0.75 grams. That's a mass of this gas at 97.2 kilopascals. The units tell me that's the pressure. And 60 degrees Celsius, that's the temperature. So we need to convert that to Kelvin. What is the molecular mass? Well, we have all of the variables we need. Little m, mass, 0.750 grams, R, 8.31, and then T is temperature, 60, so 60 plus 273, and then P, pressure, is 97.2 kilopascals, and V, volume, is 273 cubic centimeters. So here it is. It all works out. We plug it in. So here's all your variables. M, little m right here, your mass. R, 8.31 kilopascals, decimeters cubed, mole, Kelvin. There's 8.31, the R constant with all of its units. Temperature in Kelvin, 333 Kelvin. 273 plus 60 gives us 333. And then volume is 0.273 decimeters cubed. I'm going to take centimeters cubed, convert it to decimeters cubed. And I just plug it all in. Here's the pressure, and I just plug it all in, and I get 78.2 grams per mole. It doesn't tell me what the compound or the molecule is, but at least it tells me what a possibility it could be. You know what I mean? There's other clues that go along with this, but finding an unknown takes many clues, and this is just one of them. So the molecular mass is just going to be one of these clues. Let's try one. So here it is. What is the molecular mass of a gas if 372 cubic centimeters? Remember, we have to convert that to decimeters cubed. How do we convert 372 cubic centimeters to decimeters cubed? And you're right, 3 to the left, 0.372 decimeters cubed. And it has a mass. A lot of times the words just tell us exactly what it is. Have a mass. So that right there, 0.800 grams is little m at 100 degrees Celsius. And this one is nice because this would be 100 degrees Celsius plus 273. So then it would be 373.0 Kelvin and 106.7 kilopascals right here. So again, you're just going to substitute in. You're just going to plug everything in that we've talked about. And when we do that, we find, and you do the math properly, look at all the math, make sure everything is checked off. Your paper looks like this. It's 62.5 grams per mole. That's how it works out. And this is a molecular mass. Remember, we are looking at units, and so we're going to cancel the units. The Kelvin cancels out, decimeters cubed cancels out, moles are going to stay. Kilopascals cancel out, grams is going to stay, grams per mole. That's our units. Make sure everything else cancels out, and you make sure it's the right units for what we're solving for. And that's the answer. So here's the second part here. What is density equal? We did density a little bit ago. Remember, density is going to be mass in grams over volume in decimeters cubed. This is for gases, so mass in grams, volume decimeters cubed. So this is where it works out. Let me show you. It's right here. MV, there's density right there. M, little m, not big M. Big M is molecular mass. Little m over V. So we need to solve for this. So if we solve for little m over V, we end up getting MP, molecular mass times pressure, divided by R constant times temperature. Excuse me, divided by R constant and temperature. We're going to divide temperatures in the denominator. So what are the units of density? And if we have a mass in grams and a volume in decimeters cubed, then it's grams per decimeters cubed. Remember that. All right, so what will the density be of oxygen at 100.5 kilopascals and 23 degrees Celsius? So if we're solving for mass over volume, so our molecular mass, what is the molecular mass of oxygen? Remember, oxygen runs at O2. It's a diatomic molecule, O2. Each one is going to be 16.0, so total would be 32.0 grams per mole. Pressure, 100.5 kilopascals. Done. R, 8.31. And then T, temperature, is 23 degrees Celsius, and we're going to add 273 to it. So this is all the variables laid out in this fashion. So molecular mass, 32.0 grams per mole, pressure, 100.5 kilopascals, and then here's your temperature, 296 Kelvin. And then right here's your R value. Remember, R value is in the denominator, so the 8.31, the actual value goes in the denominator, kilopascals, decimeter cubed, mole Kelvin in the numerator. Anytime that R value is in the denominator, the mole Kelvin goes in the numerator. Cancel units, Kelvin gets canceled out, kilopascals gets canceled out, and then decimeters cubed is going to stay because that's part of the volume. The moles are going to cancel out. So you're going to have grams per decimeters cubed, and that's the units. Do the math. 32.0 times 100.5 divided by 296 divided by 8.31 will give us 1.31 grams per decimeter cubed. And there it is. There's your homework. We've done a couple homework problems inside the notes already. And I'll put these notes in the classroom along with the screencast, but here it is, problems number 4 through 8 on pages 380 and 381 in the main text, and you also have SPIC book problems on page 108, number 8 and 9, and those have multiple parts to them. Please read chapter 19, 1 through up through 6, and we will be discussing these on Monday. And I'll be able to do the demo for you, and we'll go over this homework. Please do it all, and I'll make sure it's loaded up for you in the classroom. I look forward to seeing you guys, and take care. Have a nice weekend.